Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on August 12, 2025, just a couple of days ago. This paper finds that most large language models can correctly follow fewer than 60% of complex, logic-rich instructions. The paper is titled Complex Logical Instruction Generation, and it really highlights a significant gap in the capabilities of today's models. To do this, the authors created a new framework called LogicIFGen and a benchmark called LogicIFEval, which automatically generate and test these intricate instructions based on computer code. Also, the authors shared their full implementation on GitHub. You'll find their complete LogicIF framework, so not just the benchmarks, but also the actual scripts to generate new instructions from code, run inference, and evaluate model performance. It's a really comprehensive toolkit for anyone wanting to experiment with this. Alright, so this first figure really sets the stage. On the left, it shows the core idea. A model, in this case a llama, is given an instruction in plain English. It then has to follow the complex logic from that instruction to process some input, essentially simulating a computer program without writing code. Now moving to the results on the right, the bar chart shows a huge performance gap. The top model, GPT-5, reaches about 85% accuracy, but most other models, including well-known ones like GPT-4o, struggle significantly. Building on those results, this diagram shows the LogicIFGen pipeline they created. It starts with a seed function, which is just a piece of code. This code is then anonymized and augmented with state trackers, which are special variables that log the internal logic, like how many times a loop runs. Finally, this modified code is translated into a natural language instruction. The correct outputs, including the state tracker values, are then used as the gold labels to verify if a model followed the logic correctly. This table then details the performance for a whole suite of models, split into thinking and no-thinking groups. You can see a clear trend. As the instructions get harder, from easy to medium to hard, the accuracy for every single model drops. For instance, GPT-5 goes from over 90% on easy tasks down to 74% on hard ones. The both column is what's really important here, as it means the model got both the final output and all the internal state trackers correct. To understand why the models are struggling, this heat map breaks down the types of errors they make. The most frequent problem across almost all models is control flow misexecution, which means the model fails to follow the core logic, like running a loop the wrong number of times or taking the wrong path in a conditional statement. This specific error is especially high for some open source models, with Gemma 327b, for instance, having over 53% of its failures fall into this single category. So, to wrap things up, the main takeaway is that even top LLMs are surprisingly brittle when it comes to following complex logic. The LogicIFEval benchmark really drives this home by showing that simply getting the right final answer isn't enough to prove a model truly understands the instructions. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.